Hi everyone, this video is on exercise 13G question 2. So we have this curve and also the line y is equal to 3, and we want to find the area of the region that is bounded by the curve and the line. So, but in part A, we want to find the coordinates of the points of intersection, which are A and B. So in order to find the coordinates of A and B, we just need to set the equation of the two, in this case, the curve and the line equal to each other, so that we can find the points of intersection. So we have 4x minus x squared is equal to 3. So let's rearrange this equation. We get x squared minus 4x plus 3 is equal to 0. So we can factorize this x minus 1 times x minus 3 is equal to 0. So the two solutions are 1 and the other solution is 3. Okay, so by just looking at the graph, we can see that A has x coordinate 1 and B has x coordinate 3. And both of them obviously have y coordinate 3 because they are also on the line, and the line, that's a constant function. So therefore A has coordinates 1 3 and B is 3 3. Okay, now part B, we want to find the area of R. So once again, R is bounded by the curve and the line. So in order to find this, we just need to understand the meaning of integration. So basically, when we want to, when we, for example, want to solve this integral, the integral that is 4x minus x squared, and that is between 1 and 3. So the output of this integral is going to be the area of the entire green region. So the output is simply going to give us the area that is bounded by the curve and the x-axis. So that's going to be the result of this particular integral. Now, obviously we know that we don't want this whole area. We only want the area of the yellow region, or the region R. So we need to find a way to find only that specific area. But before that, we also need to understand that the area of, if you just integrate this constant function, which is just 3, between, again, 1 and 3, that this integral, the output is going to give you the area of the red region. As you can see, this is the region that is bounded by the line and the x-axis. So therefore, hopefully you can realize that if you want the area of the yellow region, we can find the total, which is the green, and then take away the red region, so that we will get the yellow region. So that's the whole point of considering two different things. And maybe the hardest part of these questions is just, these are, by the way, simple examples, but overall the hardest part is just understanding how to set up the integral, because it's no longer like you just solve a simple integral and say, okay, this is the area. You need to understand how to actually get the area that the question is asking you. So yeah, in this case, so it's simply the area under the curve minus the area under the line, and that is indeed going to give you the yellow region. So because you are basically finding the total area minus the area under the line, so that will obviously give you the area of the yellow region. And again, by using a property of integrals, which allow us to basically combine the two integrals as long as they have the same limits, and also they're being integrated with respect to the same variable. So in this case, we can combine them and have 4x minus x squared minus 3. And yeah, so now we just need to solve this integral. So 4x integrates to 2x squared, and then minus x squared becomes minus 1 over 3x cubed, and then we have minus 3x that is integrated between 3 and 1. So now we just substitute 3 and then take away 1 substituted, and the final answer is 4/3. So 4/3 is the area of the yellow region.